All right, let's go over the second derivative example. So here we have y equals, it's an ugly looking function. It says y equals e is getting raised to the 1 over x squared power. But I'm not, you know what, I'm going to go ahead and change this. Instead of 1 over x squared, I can go ahead and change this to x to the negative second power, right? I mean, that's a little better, I think. All right, I'm going to go ahead and first find the first derivative first. So y prime equals, you bring that down exactly the same. Just bring it exactly the same. But now this is where we have to now multiply by the derivative of the exponent. Okay, which is x to the negative second power. All right, so let me zoom out a little bit, you guys. Y prime is e to the negative, x raised to the negative second power. And the pink part, if I multiply, or if I find the derivative of ex to the negative second power, that is going to be negative 2x to the negative third power. So we got another product situation. We must now use the product rule to find the derivative of this first derivative, because we are finding second derivatives on this page, okay? So let me set up my product rule pieces over here, okay? So product rule. Okay, I wonder if you can read everything here. Okay, so the first piece is e to the x raised to the negative half power. And as you can see, that was the original function that I differentiated. So f prime is nothing more than y prime, which is e to the x raised to the negative second power times negative 2x to the negative third power. And now g is the pink one, which was negative 2x to the negative third, and I now need to find the derivative of that. If I use the power rule here, I will multiply negative 3 times negative 2. That's going to give me positive 6x to the, and the new exponent is now negative 4. So I got all my product rule pieces labeled. I am ready to plug in to the big product rule formula. Okay, so let's go ahead and find the second derivative. Y double prime is first times, I'm going to write that down, e to the x raised to the negative second, the derivative of the second, and the derivative of the second was 6. And you know, I think I may do that. Who knows, maybe I'll be able to pull out the x. So instead of just writing 6x to the negative fourth, I separated them. But maybe we don't have to do that. All right, plus, now I need the second times, I'll write that down. Second is negative 2. You know what? I know I'm not being consistent. I changed my mind. I'll just keep it as negative 6x to the fourth, so that I have a little more room. So second times the derivative of the first. So this mess now. Okay, I'll put the e in its own parenthesis though, because you know by now that that's usually the one that gets pulled out to the front, right? Wonder if I have room. I have so much room. I just had to zoom out. So this is getting multiplied by negative 2x to the negative third power. So you may always stop the video. And oh gosh, guys, I wish you can ask me questions as I'm going over this, but let's see. Let's pull out some common factors. They have this in common, and they have, is that the only one? I mean, there are a couple more, but let me go ahead and pull that out first, and then I'll simplify inside, okay? E to the x raised to the negative second power. Open a big parenthesis. It's okay. I'm going to go ahead and put down what's left inside. And if you take a look at this part right here, we're going to have to multiply. Negative 2x to the negative third times negative 2x to the negative. Oh, we're really squaring it, aren't we? So negative 2 times negative 2 is positive 4, right? But x to the negative third times x to the negative third will give us x to the negative 6. New power is negative 6. I mean, to me, this looks pretty good. But we may want to simplify this further, okay? Maybe we can factor out. You know, I mean, that's up to us, really. To me, that looks good. I may even factor out x to the negative fourth to the front. But instead of that, how about we put it back in the fraction form? E raised to the x to the 1/2 power. Oh, no. That is what? 1 over x squared. Isn't that it? So what I just did was I rewrote x to the negative 2 into 1 over x squared. Okay? Why am I doing this? Because that's what the original function looked like. They did not have any negative exponents. I wrote them with negative exponents so that I could easily apply the power rule. That's why I did that. But now I'm done. I'm going to just put them back in positive exponent in a fraction form. So you see, there is 6 is going to be on top. But in the bottom, I'm going to have x to the 4th power. Now that 4 is positive. Plus 4 over x to the positive 6 power. Oh, I can't just stop this now. I now need to combine those two fractions. I am so tempted now. Okay. So the first e term stays the same. But if I go ahead and write down the common factor, you guys, you see the second fraction had x to the 6th power. So what I will need to do is I will multiply the top and bottom of the first fraction by x squared. Why am I doing that? If I do that, the denominator will be x to the 6th power. And I can add them now, you see. Okay? Again, just some algebra, not really calculus at this point. E raised to the 1 over x squared. And the single fraction that I can have is 6x squared plus 4 all over x to the 6th power. And if you're like, you know what, I want to put this on the same fraction. I mean, do we really have to go further? But I don't know. At this point, I'm having fun. So I may just put that on top of the fraction and have x to the 6 to be the only thing in the bottom. But we found the answer up there. That was simplified enough, really. But not sure what your MyLab homework will want. So we can go on further if you want to. But that is enough for this problem. I'm just going to I have one more left. And I'll go over that one in another video. Let me zoom out so that you can see the big picture. But I will also post the completed note on Canvas for you.